Hi, we're gonna repair today the small CCTV monitor. It starts up, but the screen is completely blank. Right, let's plug it in and see if we can get any powering. Right, the green light, probably you can't see it. The green light comes on, but there's nothing, absolutely nothing on the screen. Let's open the back cover and see what is wrong. Box on the back of the monitor. Let's put the monitor away. And what we can see on this boards, you can see the smoky film. That doesn't look good. Let's take it off. Maybe it's just dust. Oh, there's some burned elements. So this for sure that will be the power supply board. This is the main board to control the screen. Here's our power supply board. What we can see straight away, that's the dark marks on the board. That's mean the board was overheated. You can see also the explode capacitors. That's mean that probably the monitor was working for a long time, probably all the time. Maybe that was just overheated, maybe was just on top of any other devices, like for example DVR on CCTV, what was creating a lot of heat, maybe just on top of the radiator, so the capacitors get dried. What is faulty? We don't know yet. Right, what we can see from this side, we definitely have the power supply here. Here's the main socket. This looks like the bridge rectifier. Of course, the AC goes to the two middle legs, and we have the output of positive and negative voltage. The positive goes here. Here we have two small resistors in series. I believe that's the start-up resistors for this little chip. This will be the control chip. So the power supply goes here, here, and just around into the chip. From the other side, we have these two small capacitors, and these capacitors are here. So the capacitors, actually one of them, just this one, is charged first through the start-up resistors, is charged to the right voltage to run the microchip. Then the chip, it runs for a really short time to start up the main transformer here. When the main transformer starts, what the pins are here and here, then the auxiliary winding will just create some voltage, and as you can see here, the voltage will go through the capacitor again, through another one capacitor, and that will supply the microchip. We have a quite nicely explained what the pins are. So this is some kind of adjust. Don't know what is it for now. This is ground, 5, 5 and 12 volts. On this little socket is a LED for LED 3, V in, LED 2, LED 1. So that's the supply for LEDs. Right, let's see what we can do with this board. Definitely, for first thing, what I'm gonna do, I will just replace these capacitors. I will also check this too, and there's not many more. So let's take them out, these two, and test the rest of them. Okay, so we have the capacitors out. Right, actually, what the capacitors do on this board, we can quickly check how this works. This is the main transformer, and actually only one on this board. On this side we have two big diodes here and two big diodes here, so the legs are here and here. So that's the pins from the transformer. When we have a diodes on this side and diodes here, we must have a 1 voltage here, so that's the positive voltage. For example, we'll say 5 volts, and then we have the second voltage, positive voltage here, for example 12 volts, and the middle one will be ground, what actually is going straight from here, and actually we have some marks here, ground. We have a 1 voltage here, diodes, the diodes on the opposite side that go here, so we have a 1 voltage here. Then we have something, this is just the bridge. So if this is just the bridge, there will be the same voltage on this capacitor, and that is a 25 volts capacitors. And so I believe, because we just had a 5 volt and 12 volt on this board and nothing else, so I believe this side is a 12 volts one. Because on the other side the capacitors are only 10 volts, so I believe this side, that's the 5 volts power supply. Are the capacitors only components what actually are faulty and we didn't have any supply for the monitor? Is a big chance that actually this happened. If we have no capacitors just after the bridge rectifier or the rectifying diodes, then the voltage is not smooth. So there's some electronic component here, as we can see, may just switch off to stop the voltage from going through the diodes, basically to save the diodes. Let's test the diodes as well and see if the diodes are not faulty. Tester on diodes, of course. We're just checking the forward voltage. That's 0.3 volts. This is 0.3 volts. Let's try this from the other side. Nothing and nothing. That's absolutely fine. Let's do the same thing with these diodes. I don't think that will be something wrong. These diodes have even lower voltage drop. Another one, opposite side. Right, there is some low readings, but it's just charging the capacitors, so that's absolutely fine. We can see there's basically the reading goes up, so that's mean it's just charging capacitors. Right, let's test the other two capacitors now. You need an ESR meter just to test the capacitor correctly. What I'm gonna do first, I'm gonna just connect the old damaged capacitor. There's nothing at all, so that's definitely gone. Let's see the other one. Right, we have some readings, but the readings are quite high. From this table on the bottom, we can see that for capacitors at 25 volts and about 680 microfarads, we should have a reading about 0.1, and we have a reading 29, so that's much too high. So the both capacitors are definitely gone. As we can see on the back of a capacitor, is just explode. Let's test the other two. Another thing about this tester, you can test the capacitors soldered on the board. The readings may be not always correct, but if we have not correct readings or the readings are really high, then we can of course desolder the component and test it again. This is the 0.014, so this is very low and it will be good for any capacitors, for any with any capacity. Let's test another one, and again this is quite good. Right, so we share these two capacitors are okay. Let's test the two little ones. We should have a 1.5. That's much too high. So this one is probably faulty, and the another one we have no readings at all. So right, we need to replace this two as well. Let's see this one. Right, this one is good. The tester is just showing it's alright if the capacity is less than 330 microohms. So in this case, this one is absolutely fine. So right, I'm gonna replace the 4 capacitors and then we'll see if the board starts. So here we go. There's some capacitors second hand. I don't recommend to use the second hand capacitors. Of course, there's second hand capacitors are good for a project like this, not for any customers, not for sell. Basically for myself it will be absolutely fine, because the capacitors have a limited life. So if there was already in the device what was working for a few years, and then we're gonna use the same capacitors on the another device, it don't gonna last for long. So if you can, you always using brand new capacitors. Okay, so we have everything on. Ground is here, 12 volts here. Right, 13 volts. That's good. What about 5 volts? 5 volts here. 5 volts on the 100 pin. 5 volts. So the 5 volts is quite accurate. Okay, so let's connect everything together and see if it works. Right, all connected. Power on. Alright, we have a little green light. Ah, there you go. This is my screen from my computer. Right, looks like everything works. Just by replacing 4 small capacitors worth probably £1. Of course the screen is cheap Chinese screen, but I will just replace my old screen on my CCTV. So well done. Thank you for watching. See you in the next one.